Hey, what's going on everybody? This is Nick from Part-Time Pilot. Today's video is going to be on how to get weather for your cross-country flights. That's how to get weather to calculate stuff and how to get weather en route. You know, the weather you're going to have en route to look for hazardous weather and all sorts of stuff like that. We're going to show you where I go to get all that weather and show you exactly me doing it and an in-depth example. So let's get to it. As you plan cross-country flight, you will need certain weather data in order to make calculations. Things like winds and temperature aloft, surface winds and temperatures, altimeter settings. But even if you use a flight planning software to do most of the calculations for you, you will still need to look up the weather at your planned airports, alternate airports, and in and route altitudes to make sure, nothing has changed when you look up the day of from your flight plan, but also to look for hazardous weather, TFRs, and stuff like that. So we're going to want to look for things like ceiling and visibility, hazardous weather, things like icing, thunderstorms, winds, turbulence, and then even surface winds for landing and takeoff. So we got to calculate that performance as well, and we want to know if we're going to be landing or taking off in any crosswinds. The first thing I recommend doing is looking for hazardous weather en route, TFRs, etc. Because if you find hazardous weather for a TFR that cancels your flight or completely changes your cross-country route, then you'll want to know this before you put in all that work to calculate your flight plan. Here are the tools and weather we will look for in order to do this. So we're going to use aviationweather.gov, the GFA tool. It's actually aviationweather.gov/GFA for ceilings, precipitation, icing, turbulence, and much more. And then for TFR and NOTAMs, we're going to use tfr.faa.gov. And then we're going to go back to aviationweather.gov for the prognosis charts. And these are like a high-level view of significant weather in our route. If you're going to do a small cross-country flight, you'll likely not need these as much. They're mostly used for longer routes, but they are a good thing to look at and a good kind of place to start. Get that high-level bird's-eye view of everything, and you can find those at surface, low, mid, or high levels. So we'll get into that and show you what that looks like. So let's first go and show you what the GFA tool is all about and how we would find weather for our route. Alright, so here we are on Google, and we can just type in aviationweather.gov, GFA. You could also do aviationweather.gov/GFA. That would be probably much easier if you can remember that. And then you can just click here, and then here is the GFA tool. Now you could also, under here, forecasts, you can click on area forecasts, and then here it says, yeah, we use the GFA tool now, so you can click right there. Alright, now you can zoom in and out to pretty much anywhere in the United States, and we're going to focus mostly on Southern California for our example flight. And then you have these different tabs here. We're going to start from the left. So you have TAF, ceiling visibility, clouds, precipitation, and so on. And then you have this bar, and then sometimes you're going to have a vertical bar. So this bar here is the forecast time. So right now we can see we're looking at a 1 hour ahead forecast at 2300 Zulu. But let's say we're planning this flight, the night before, and we're flying the next morning. So let's say we're at like 8 p.m. and we're planning our flight, and we're going to fly, at 10 p.m. So 14 hours ahead of time, or 10 a.m. the next morning. So we'll go to 14 hours ahead of time and look at that, the time of our takeoff, and then we can even go, okay, our cruise, when we're going to be in cruise flight, and then, maybe if it's a 3-hour flight, like when we're going to land. Okay, so that's a really cool, feature here that you can just scroll along, and then all this information will change. And this first one is just a graphical view of the terminal area forecast. So as you can see at airports that have a terminal area forecast, you have the wind barb, and it's going to tell you the speed and direction of wind. And then it's also got this, little round thing, which it tells you what it is down here. So whether or not it's full or not, it's going to tell you, the sky cover, sky clear, few, scattered, broken, overcast. And then the color is going to tell you, the flight rules. So LIFR, IFR, MVFR, or VFR. And so tomorrow morning at San Diego, there's going to be a marine layer, so it's going to be IFR. Okay, so that's just one thing to look at. So we'd, for a VFR pilot, we're leaving 𝐏𝐤 we would want, or even, Montgomery Field here, we would want to, wait. We would want to see, okay, when does that no longer IFR, and see when does that marine layer clear up, and and it looks like it's going to be around there for a while tomorrow. But anyways, some of the ways you can use that TAF tool. Next one is the ceilings of visibility. This is kind of a cool heat map by color of the flight rules. So same sort of thing, but it's just an easy visualization, where you don't see anything. That's going to be VFR. And then you can see, again, tomorrow morning, this marine layer is going to give us low IFR and IFR conditions in the morning. And that encroaches on the land a little bit. Okay, now the next one is clouds. This is, again, is like basically the TAF, the cloud data in the TAF, just put on a map. So if we zoom in here, right here, this tells you the different cloud layers. So overcast at 003, that's going to be hundreds of feet. So 300 feet. The top of all the layers is going to be at 017, that's 1700 feet. And then, broken over here at 008, so that's 800 feet, and so on. You get the picture. Next one, precipitation and weather. Again, another heat map of precipitation and weather. And then again, it has this legend down here that tells you everything. So we see yellow, so that, if we look over here, that's fog. So we get this marine layer fog here. But if we zoom out, we see some green out here over the Pacific Ocean. That's going to be rain. And so that's a chance of rain. And then if it's dark green, so as you can see, that rain, all the precipitation, rain, snow, mix, or ice, it has a chance, that there's a chance of it, and that's going to be the lighter color. And then if it's likely, more likely, it's going to be the darker color. So if we look here, like the dark green right here, it's very likely rain. We even get some red, which tells us thunderstorms. So we got likely chance of rain and thunderstorms. We even have the thunderstorm symbols here. And you can even click on these, and it's going to tell you, the text version of the TAF. So really cool tool. So let's continue on through here. Let's go back to Southern California, and let's check out this thunderstorm. Actually, there's no thunderstorms in Southern California. So let's zoom back out. And again, we have these thunderstorms over here in red, this scattered thunderstorms with 30 to 50% chance. Isolated is going to be the lower chance. And then again, you see these figures, and then the dark red is going to be numerous thunderstorms there. So now if we continue on, so that's thunderstorms, we can look for wind in our route. So if our route is here, we looked at thunderstorms, right? We didn't see any. We looked for winds. And now you see this new kind of bar here. Now we can choose the altitude level for our data, which is really, really cool. So we can look at the surface. We can just look like all the maximum winds, so the maximum wind at any of these levels. We can look at the surface. So we can look, if we want to look at where we're taking off from, that airport, we can look at that. And what's cool here is the wind speed is also, color coded. So, we have real light winds here. The blue, picks up to like 10 to 20 knots. And then when you get yellow, orange, red, it's getting up to near, even in red, over 120 knots, which we might be able to see if we climb altitude. So first, what I would do, you could use this, like let's say we're cruising at 6,000 feet. You can go to 6,000 and you can see the winds. Really easy to see the winds for your cruise. So if we're flying right here, right, you can just go, okay, well, I'm taking off at this time, and then an hour into my flight, the winds are still about 10 to 15 knots, and they're all about from the northwest, according to these, wind flags. They're coming from the northwest, and it doesn't change much. So it's a really easy way to see the wind during your flight and all that stuff. So really cool tool there. And then as you can see, if we go up real high, we get some yellows and even some reds up here, which again are up to 60, 80 knots or something like that. Because as we get higher, usually the winds get much higher. So that show you that there. And then we have LLWS, which is low level wind shear. It's going to show you, the wind shear amount, again, color coded. We don't have any really anywhere right now. It's midday, so yeah. And then you go to turbulence. Again, really cool. If if you're not a fan of turbulence, or even if we don't want to fly, with our aircraft can only handle a certain amount of turbulence, so we want to avoid severe turbulence in general. So we want to look for, stuff that's in the orange or red. Or even if you just don't like turbulence, you can kind of get an idea of how much you don't like, and you can kind of decide, well, you know what, I'm not going to fly today. even if it's in like the yellow, and that might be your personal limit. So really cool. You can kind of see the turbulence around the US or on your flight path. And then finally, one more thing is you can change again the altitude. So we can go to 6,000 feet, our cruise altitude, and see as you get lower, you get a little bit more turbulence, right? So make sure you're on the right altitude, like I wasn't for a second, but yeah. So again, you can change your altitude. It's really cool. And then finally, you want to look at icing, right? So you want to look at the highest, your cruise altitude, the highest altitude you're going to be at as well, and just see if there's any icing. And again, it's color coded by severity. Let's see if we can find any. It's tough because it's in the summer, so we might not find any. Yeah, so that's okay. I think we have a little bit of trace icing here in like what, Colorado? Is that Colorado? Yeah. All right. So anyways, it's probably in the Rockies. So that is the GFA tool. So we'll show you how to use that in a little bit. But let's go back to our slideshow and we'll look at the next tool. Okay, so the next tool is going to be tfr.faa.gov, and that's going to be for TFRs and NOTAMs. So let's go back to Google and show you how to do that. Alright, so we're back at Google, and let's go FAA TFR NOTAMs. And again, I told you that it's tfr.faa.gov. You can also just, if you remember that, you can type that in. And now it's going to give you this list. I'm not a big fan of lists. I like to use, you can do airport maps. You can search for specific NOTAMs. You can do a list, which we're on, or you can do the map of TFR. So that's what I like to look for here. It's not as nice and movable as the graphical area tool. Not sure why, but I just like to kind of zoom in, on. Oh, that's why. The reason why is because once you zoom in, it's the sectional chart. So that's kind of nice. But so I like to zoom in and see, so I can see my entire route. So if we're let's see here. Okay, there we go. So we're about like right here. This is our route about right here. So as you can see, there's no TFRs, but I can look here at different dates. So maybe if my flight is on a different date, you can look and you can read. You can even click on them, and you can see when they are going to be. So this is a snapshot of right now. You can zoom to a center. You can zoom to a state. You can, and then again, here's a legend of the NOTAMs and stuff. And as you can see, a TFR is going to look like just a red circle like this. Or sorry, this is a NOTAM. And yeah, so you just want to look during your time for your flight. You want to zoom in right on your area, and you just want to make sure that there are no NOTAMs or TFRs during your flight time. Okay, so, and there's another way that we'll show you how to do this, but this is the first way. Let's see if we can find one. So there's one right here. As you can see, there's a NOTAM right here. And this list also is updating, right? And this is for Yuma. So we can click on this and we can get more information. So that's an example of how to find TFRs and NOTAMs for your route. All right, now the last thing I want to show you is, again, aviationweather.gov, and we're going to look at the prognosis charts for surface and low-level significant weather charts. So let's go and check that out. So here we are back at Google, aviationweather.gov. Let's just go here, and then if we go to forecasts, we can go to prog charts right here, and then it's going to bring you to the prog chart page. You can click on it, area of the world if you wanted to, or you can scroll down and you can just kind of do the United States. So I like to do the surface plot and then the low level, because the low level is surface to 24,000. So as a general aviation pilot, we're not going to go any higher than that. So let's look at the surface plot. Now this is just significant weather, so this is kind of what your weatherman is going to show, with the H's and the L's showing the pressure systems, the troughs, and any weather fronts. So one thing, obviously our route, our example is just down here in Southern California, it's not really traversing through and changing any pressure systems. But if you see a pressure system right where you're at, that can be a sign of things changing, or sorry, a front right where you're at, that's be a sign, or maybe a front to the left or right of you moving in a direction, a sign that the weather is changing and you might get adverse weather, because when different air masses mix, that's what creates weather. So, and then again, you kind of want to avoid low pressure area. Low pressure is usually going to be, associated with worse weather. So you kind of want to, if you were to fly a flight across the United States, you can kind of just fly through the H's if you wanted to. So it's just a cool kind of tool to look at the different fronts, where the air masses are kind of moving. It's a bit confusing, but you can even get, the weather here in millibars, or the pressure in millibars on these ISO bars here, these gray lines. That's where the pressure is all the same, and you can see when these gray lines are stacked close together that the pressure is changing a lot in those areas. And then as you can see, these lines get all squirrely around here over the Rocky Mountains, and so the pressure gets real weird in here, and that's why they have so many different H's and stuff like that. Down here we don't have much to worry about. We have the Sierra Mountains, which there's a pressure change over there, but we're just going to be right over here, so we're good. We're in kind of a low pressure area, but we're not in any fronts or anything like that, or areas where there's a bunch of isobars changing our pressure. Okay, the other one I want to show you is just the low level significant weather chart. I'll zoom in on this for you here. Now, again, this is just going to show you, like in red, it'll show you basically like IFR areas, and then it'll show you like MVFR, and then if there's nothing, then that's going to be VFR. So you can look kind of around the United States and kind of see where there's going to be low level clouds, right? Yeah, you got over here on the coast, again, we saw that already, that's going to be IFR conditions because of the marine layer. You got IFR conditions up here in the Northeast, and then you got some like marginal VFR, and in between IFR and VFR here with, again, ceilings between 1,000 and 3,000 feet and visibility between 3 and 5 statute miles. You even can see the freezing level, kind of high level, freezing level above mean sea level here. That's really not going to, I like to use the graphical forecast to see if there's any freezing or icing at my exact altitude. This, for a short little flight, this is not going to be very helpful, but if you were taking a longer flight, and flying through, for example, freezing level at the surface would definitely be something you'd want to pay attention to. Over here you can get, some turbulence. This, moderate turbulence signals here, and then it tells you the altitude in hundreds of feet below it. So just high level, really high level stuff. We go over, again, in detail how to look at the stuff in the course. But yeah, so that's basically, this is a good place to start. If it's more so if you're doing, again, longer flights, but you can kind of look and get the general area, that you're flying in, see if there's any significant weather. You can look at the surface plot and just kind of see, is there, could there be big weather systems coming in that I need to worry about that would bring adverse weather? Okay, so let's get back to the slideshow and talk about some more weather stuff and where to get weather for your cross-country flight. So next we need to zoom in on our cross-country plan and get more detailed wind and temperature data. So let's go back to our example. Let's make it a little more specific. We're going to go from Gillespie Field, KC, to Apple Valley, KAPV, in Southern California. So it looks like this. We're down here, KC, which is just east of San Diego, and then we're going to fly to Apple Valley, which is here in the eastern part of California, east of the Sierras from LA. So it's going to be hot over there, but we're going to kind of do that route as our example. All right, so once you have chosen your checkpoints and altitudes and then measured your courses and distance, you'll need to gather wind and temperature aloft information for each point of your flight. So I'm going to bold the things. Those are the weather reports we're going to need and search for. So I'll bold those here when we talk about them. And then this flight plan, if you're interested in how to do this cross-country flight plan, we have videos on that, and we go into detailed examples in the course. So if you're in our course and you're looking for that, don't worry, we'll get So don't worry about calculating all this other stuff. We have lessons for that. We're just focusing on the weather in this video. So this includes stuff like takeoff and landing, surface winds and temps, and then winds and temps for climb, cruise, and descent. So all those checkpoints and altitudes in between the surface and cruise as well. So here we want to, again, Google aviation weather. And if we did that, it would pop up, something like this. Or go to aviationweather.gov and then search for winds and temps link. So you can search and just click right there. And then you're going to see this, and you can click on the general area. And you can see there's a pretty big area, right? So if you were like taking off from right here, you just want to pick the closest one. You pick the Las Vegas Center if you're taking off right here. Or sorry, I don't know if you can see where I'm pointing. But anyways, we're going to do San Diego because we're flying from San Diego to the bottom of ONT. We're flying north to the bottom of ONT. So we're going to click on the San Diego one and use that weather. And then we want to make sure once we're on the winds and temps data that we want to change the time frame. So so we want the forecast for when we're going to fly. So we'll change that time frame. It's a time frame in Zulu, so you want to make sure that you convert the time of your flight to Zulu so you know when that's going to be. So we're going to say we're assuming noon local, so we pick the 18 Zulu to 006 Zulu. And then you find your station here in the table, and then you have all these altitudes. And again, we have a video on how to break down and read this. So I'm not going to go into details on how to read all these things. Just going to show you, this is the weather, this is the information we're getting, and how we're going to use it. All right, so then if we go back, we're going to look at our altitude, our cruise altitude. So if that's 9,000, we would then want to follow San Diego over and find that 9,000. So this cell right here is our data. So our altitude in our our example plan is 8,500 for cruise. So that's between 6,000 and 9,000. It's pretty close to 9,000. So you could interpolate, but it's pretty dang close to 9,000. So winds at 9,000 is 240 true at 31 knots. So 240 at 31, and then plus 11 degrees Celsius. So we're going to put that in for all our cruise altitudes, and then we'll continue on. Now we need to fill in the rest. As you continue on through your cross-country plan, you will determine exact altitudes you want to hit at each of your checkpoints. So when we do our climb performance, that's when we're going to figure out these altitudes. And as you can see, we kind of did that here in the background. We can get this information using, again, winds and temperature aloft data, but we may have to interpolate at some of these other ones. Or, again, like I said, if it's close enough, we can just go with that. So we can also get wind and temperature data at the takeoff and landing airports using airport TAFs or local area forecasts. So we'll show you how to do that. So we want to get wind and temperature. I don't know why this temperature data is in here right now. Just ignore that for the KC checkpoint. But we need to get winds and temperature data for our takeoff airport and our landing airport. So KC and KAPV. If our airport doesn't have a TAF, we can use local area forecast. So that's what I mentioned. And again, I'll show you how I do that using aviationweather.gov. So find the altitude column we need data for. So we're doing our KRNM checkpoint at 5,300 feet. So we're going to go to the 6,000 row, and we're going to read that off and say 260 true at 17 knots, temperature of 13 degrees. So we'll fill that in for the KRNM checkpoint row. And next we need to do the Lake Jennings row at 2400, but there's wind data at 3,000 feet. If we look back here, there's wind data at 3,000 feet, but there's no temperature data. So for temperature data, we're going to have to interpolate between the surface and 6,000. So so for the winds, we can just use 3,000 because it's pretty dang close. So 3,000 feet is going to be 330 true at 5 knots. So we put that in there. And then again, for temperature, we're going to have to interpolate between the surface, which is at KC at 508 feet, and this is a pressure altitude, and then Lake Jennings this row, which we use data at 6,000 feet. So we can get this from a terminal area forecast for our airport, KC, or if our airport doesn't have a TAF, we can use a local area forecast. So KC does not have TAFs, so we're going to use a local area forecast to get, the temperature at our surface so that we can then interpolate between KC temperature and then the temperature at 6,000 feet of 13 degrees. So again, KC doesn't have that, so we're going to use the local area forecast tool at aviationweather.gov. So we'll just go to aviationweather.gov, and there's a little search bar in the top left, and you just search, that's closest town to your airport. So that's 𝐏𝐤𝐥𝐿 here. And then it's going to have this little map, and you can actually click exactly on the map where you want, and it'll show you the green is a forecast area. So we're going to click right on Gillespie Field. And then you can scroll down, and I love to use this hourly weather forecast graph. I think it's one of the most valuable tools at graphical area. So you just click on that graph, and I'll show you how to do this in live time here in a second. And then it's going to pop up like this. And again, you can see it's got all these time on the x-axis. So from 2 p.m. and then you go to, and it even shades the nighttime. And then it shows you it goes to Monday. And this example is from November 23rd, 2020. And then you have, the next day on Monday, and then it goes to Tuesday. So you have a wide range of forecasts, and then you have these different lines. You have the up here. So the red is on the very top graph. The red is temperature. The red line is temperature. The blue line is wind chill. Green line is dew point. In the middle graph, you have winds information. So you have, wind gusts and surface wind, miles per hour. And then you have the little wind flag, which tells you the direction at each hour of the day. And then even further below, on the last one at the bottom, that even tells you the sky cover, precipitation potential, and relative humidity. So really cool chart. I love using this chart. And then so you just find your takeoff time, right? And you read off the temperature at the surface of your, and you can even get the wind forecasted right there for your airport. So we're going to take off at 12 noon, so we get the wind and the temperature data. All right, so again, the flag points in the direction, so that's like 210 at 3 knots. And then again, the 3, that's the y-axis on the left-hand side. So the grid lines are 0 and 10, so you can see the wind, the purple line for wind, and it even says 3 next to it. That's at 12 o'clock, that's right at 3, and then it goes up to about 7 knots at about 1 o'clock. So 210 at 3 knots. So we're going to put that in there for our surface at KC. And then now we have the KC temperature at 19, and we have temperature at 5,300 feet at KRNM checkpoint. So now we can interpolate our Lake Jennings, which is in between that. And if we interpolate between 508 feet and 5,300 feet for 2,400 feet, we get 17 degrees. So we can interpolate, we can get that. And then lastly, we have to do it for our landing airport. So we're going to do the same thing using local area forecast. We type in Apple Valley, which is closest town. We click on the map. We get this graph again. We find our time that we expect to land at. And then again, we read off the winds. Temperature 42 degrees Celsius, a hot one right now. Again, this is a different date, obviously, of when I'm making this video. I kind of use a couple different charts, but I'm going to show you this live here in 1 second. All right, so we put that information in, and it had some gusting winds. So we put that 17 gusting to 28 from 215, and the temperature of a whopping 42 degrees. So this temperature doesn't exactly match the other temperatures. So all this information is not accurate. Again, the point of this video is to show you where I get this information from. So let's go and show you where to get that information on actual aviationweather.gov. All right, so here we are at aviationweather.gov. I'm going to zoom in here a little bit so you can see this. If you look at this search bar, this is on every page. This is a local area forecast. So if we type in 𝐏𝐤𝐥𝐿, which is the closest city to Gillespie Field, click on that. It's going to bring up, forecasts, like you'd see a detailed forecast, all sorts of data, and then you scroll down, you get all this other stuff. You get this map one that you can zoom in on, and you can even, click and make it even more right on, there's Gillespie Field right there. So we can click on Gillespie Field and get that forecasted area right on Gillespie Field. And then scroll down, this is the one I'm talking about, the hourly weather forecast right here. We click on that. It's going to bring up this. I'll zoom in on here. You can change what you see on here, and you can do submit, and it's going to kind of update that. And you can, I like to do this, I like to print them off for my flight. I think this is very valuable here. And then you can even change the 48-hour period of time. So let's say, you want to have your 48 hours start on, Monday at 11 a.m. You change that, you click submit, and it's going to start at Monday at 11 a.m. and then go 48 hours after that. And so let's say we were taking off Tuesday, July 4th, 4th of July. That was the day we're taking off at noon. So we're going to look right here, right? And our temperature is here in the red. So we look up here and it says 88 right there. And again, we have it over here on this axis. So we're about 85, between 80 and 90 at noon. So 85 degrees Fahrenheit. And then you can you change that? No, you can't change it to Celsius, but that's okay. And then again at noon, we can convert that to Celsius later. You can look down here in this middle one and look at the winds. And the winds are from the west. These wind flags are basically from the west. So that's like 270, 260 maybe. And then right about 10 knots. So 9 or 10 knots here. Again, you can see it over here, or it kind of labels them every so often on the purple line. And then this up here would be the gusting, right? The dark blue line. Don't quite get gusting yet if we take off at 12. So that's not quite in the forecast, but we might want to be expecting it because it's very, very close. All right, so that is the graphical area tool. Again, like I said, I print this off and take it with me on my flight because it's like a little forecast for any hour, So it's a really, really cool little thing. Forecast can be wrong, of course, but I like to have this with me. I think it's really, really helpful. All right, now before we move on, I mentioned earlier that these are pressure altitudes because we want to use them for calculations. And so you're going to have to convert these to a pressure altitude, because when you get an elevation or a true altitude, you need to convert that for non-standard pressure difference for a pressure altitude. And then when you want to use a pressure altitude when we start our calculations so that we can get to a density altitude and know our performance. So anyways, how do we get to the pressure altitude? Well, we have to know the forecasted altimeter setting. And that can be a little bit tricky because not every airport has a TAF, as I mentioned, a terminal area forecast, where you might find, right, you're usually going to find your pressure setting in inches of mercury in like a METAR. And you might find those in a TAF, but they're not always in a TAF, and not every airport has a TAF. So where do we find this? What do we do? So I'm going to go back to aviation weather and kind of explain what I do for this. So there's several ways you can do this, but I like to go to the prognosis charts. Now you can do the surface, or you can do, low level. You can click on low level. And you can see these isobars of pressure, and that's what we want. We want the pressure setting, right? Now, the label is 1016. What the heck is that? That's a millibar. So we can actually convert that. So for our area, we're right here on this 1012, right here in San Diego. So for our takeoff, we're going to be 1012, and then our landing is going to be right up here. So that's also about 1012. So it doesn't really change for this time. Again, you can change the time frame here. We want to make sure we're at the time frame of expected takeoff, expected landing, right? So we'd want to do one for takeoff. Let's say it's this time. It's okay, 1004, and then let's say okay, 3 hours later. This is every 6 hours. So, if it's a 3-hour flight, see how it changes and maybe interpolate. So let's say right here 1004. So you can just type in Google millibars to inches of mercury. We can type in 1004 millibars. It's going to give us the pressure setting of 29.6481 or 29.65 I would use. And so yeah, that is one way you can do that. Another way is, let's say your airport is right next to a larger airport. Larger airports usually have that information in their TAFs. So the only thing you want to be careful of is if that airport has to be in a geologically similar, not geologically, I guess geologically, but terrain like similar area. You can't like use an airport that's across a mountain range, for example, because as you can see, areas of like mountain ranges, the Sierras, the Rockies, they have a lot of pressure changes. So if you go over the mountains to get that TAF data and use that pressure setting, that's not going to work exactly. So you can do that. The other thing you can do is you can look here and you can say, okay, we're taking, this is today. Let's say it's Monday and we're taking off tomorrow, Tuesday. You can look at Tuesday and you can kind of compare. Say, okay, on Monday, right here in San Diego, it's 1008. And then tomorrow, you can go, okay, so tomorrow, it's 1004. It hardly changed. And there's no, like, fronts came in. It's still a low pressure system over here. There's no new fronts over here. There's not, like, if a H popped up like right over here, I would be a little bit worried. So there's no air masses, no new air masses moving in. So you could just find the pressure setting of the METAR, and I'll show you how to do that next, of the day before. As long as the day before's weather is going to be pretty similar to the next day, you can do that. But I like to use this. But let's show you a METAR real quick. So if we go up here, I believe under forecasts, or maybe it's not forecasts. Yeah, observations. So forecast obviously is going to be the TAFs, and then observations. So you click on METAR, and then it's going to have the graphical METAR. So you can just zoom in to your airport and get a METAR of the airport. Or what you can do is you can come down here, you can type in the IDs of the ICAO codes with a space in between of your airports, and then you can say raw or decoded. And so I like to do decoded because it helps you out. You don't have to like decipher it as much. Most recent only, or you can do like the past 24 hours. It's going to show you all the METARs in the past 24 hours. So this, like I said, is a way you can say, let's say you're planning this at 8 p.m. and you're going to take off, tomorrow, the next day at 10 a.m. You can go, let me see the last 12 hours of METAR so I can see what it was today at 10. I can see that because I know the weather is going to be about the same. I can see what that METAR was. I can see what that pressure setting was. You don't want to copy the exact METAR, but the pressure setting, as long as there's no air mass that came in, the pressure setting is going to be about the same. So let's do that. And you can also include a TAF if you want. I'm not going to do that right now, but you can include TAFs. And you can go get METAR data. And now you can see it lists all these for KC first. And then KAPV down here has no data. It has no METARs. So we don't have that data. So we'll have to use, like we did, the local area forecast tool that I showed you. So anyways, we can see, right, we can look at, this is on the 2nd at, 2247 Zulu. So we're going to find that time the day before, and this is chronological. So we find that time the day before, and we look at the pressure setting, right? The altimeter setting, which is going to be right here. I don't think it says it. Yeah, it says it in the decoding as well, right here. And also tells you the millibars. So you can say, okay, well, today at 10 a.m. it was 29.87. There's no new pressure systems coming in, no new weather systems coming in. So tomorrow at 10 a.m. it's probably going to be 29.87. You can even look how it changes, right? 29.87, 29.88, 29.9. It's going to change, throughout the day as it gets warmer, but it's not changing a ton, right? And then you can kind of see, you can even look, you can see the trends. And it goes back to 29.87. So it is. That's what I like to do to get my pressure setting to calculate my pressure altitudes before I do my performance calculations. So we got all this, and now we have the temperature and wind data that we can use to then do our cruise performance, do our density altitude, and get our wind correction angles and ground speed. And just note that, and that's what we've done here kind of in the background, but again, this is a Frankenstein of different data that I just used, so don't look at the values of this. That's what this note says here, and don't be like, why did he get this? That's not what I got. So don't calculate these things. Again, go to our cross-country planning videos and course lessons for that. This is just a focus on the weather data that we're using. Then you can finalize your cross-country flight with time and route, fuel, and fuel consumed calculations, right? So once you have your ground speed and all that, you can finish that up. And that's, again, what we're kind of showing here. But again, the data is not accurate. All right. Now, so I like to use forecasted winds and temperatures to calculate my takeoff and landing distances prior to the flight during the planning stage. So the last thing we kind of want to look at for calculations is takeoff and landing distances, right? To see if we have enough runway, especially landing in Apple Valley. If they have a short runway for some reason, because it's so hot, the density altitude is going to be pretty high. It's also a pretty high airport, has an elevation of like 4,000 feet. So then you add, it's going to be 42 degrees, and that's going to be a pretty high density altitude and change our performance quite a bit. So I like to do my takeoff and landing distances. Like, let's say I'm planning this the night before at 8 p.m. I like to calculate them then based off forecast data. But then I like to redo the calculations on the day of the flight with the most up-to-date wind and temperature data. And what I can do is I can just, instead of like just redoing it, I first look to see, okay, here's what I had forecasted for winds and temperatures, and here's what it actually is, 2 hours before my flight. And if it didn't change or didn't change much, then I'm okay, right? But if it's a close call, one, you want to, like a density altitude at a short, like we talked about, high density altitude at a short airport, you definitely want to make sure you have the most up-to-date data and really make sure you want to make that flight and make that takeoff or landing. So I do that using, right a couple hours before the flight, I use METARs, TAFs, local area forecasts, which we have shown you. Now, finally, you can use ForeFlight or 1-800-WX-BRIEF to get an Outlook briefing to get a lot of the same information that we just got for your flight. Particularly like, the high-level stuff like hazardous weather, prognosis charts, TFRs, NOTAMs, in and out. Really good. I would do an Outlook briefing on my ForeFlight right after I just did everything we did, right? I planned my flight. I got all that information. And then I would do an Outlook briefing to see if there was anything I missed, right? And then I would do a standard or abbreviated briefing the next day, again, a couple hours before my flight. Maybe I would do it a couple times to, again, just make sure that nothing has changed. And last thing I do, and this is what I do for my check ride, because the examiner can ask you, where did you get this data? And you really want to be able to point to exactly what data you have. I don't print all this off, but I make a little folder and put it on my iPad, and then I might print a couple of these things off. But this is the kind of data that you want to have, the stuff you want to have for your flight, like in a flight folder. You want to have your sectional chart, you want to have, your performance calculations. You don't need to print those off, but for your check ride, I would, right? So you can show all your work. I think they actually ask you to do that. But anyways, so we have all this data. We have, AFDs, we have, precipitation forecast, turbulence forecast at different altitudes, prognosis charts, and, KC and KAPV local area forecasts. So I like to have as much data as possible with me and have backups of that, hard copy backups. Okay, so that's it. That's how the weather I use to plan a cross-country flight and to look forward and ahead of my flight. It's mostly aviationweather.gov with a little help from Google here and there. And then, and ForeFlight as well. So hopefully you guys found this helpful. And if you have any questions, don't hesitate to ask.